Ladies and gentlemen, what you learned last time when you met in Algebra 2 is you learned how to graph an exponential function, either exponential growth or exponential decay. We're going to take those exponential functions now, and we have special formulas for them, and we're going to talk about applications of exponential functions, okay? So the first one we're going to talk about is interest that is compounded periodically, okay? So we have this formula here, and we have to understand what all of these letters mean, okay? First one I'm going to start with is this A. We want to calculate a total amount at the end. So A stands for the total. I'm going to erase, I'm not going to put T there, I'm just going to put the amount. The amount at the end. What are we looking for? Okay? P. P stands for our principal. What did we initially invest in or start with? So this is our starting point. R, right here. This stands for our rate. This is our rate of either, of appreciation. How fast we're going to make money if we invest it into the bank. What is that interest rate? Okay? The important thing about the rate is that you need to make sure that you change it from a percent to a decimal. How do I do that? You just divide by 100, or you take that decimal and move it 2 to the left. This N here stands for the number of times per year our money is compounded, meaning how many times is that interest rate going to be applied, and we're going to make a little bit more money. And then this T right here, so we have N is twice. The T is your time in years. How many years are you going to leave your money in the bank, okay? How many years are you going to leave your money in the bank? Now, there are some possible different N's that you might experience. If it says that your investment is compounded daily, N is equal to 365. Quarterly, that's 4. Weekly, that's 52 because there's 52 weeks in a year. Monthly, that's 12. Annually, that's 1. And semi-annually, that's 2. Okay, so just some different keywords you're going to be looking for so you know what your N is equal to. Let's practice together. You deposit $5,500 in an account that pays 3.6% annual interest. Find the balance, okay, after 3 years if the interest was compounded monthly. So let's digest the problem. You deposit $5,500. That is our P rate here, our start. 3.6% annual interest, that's our rate. Now remember, we need to change this from a percent to a decimal. So I'm going to take that decimal, move 2 to the left, and our rate is 0.036. Find the balance after 3 years. This is our time in years. Here's our T. If the interest was compounded monthly, monthly then is N is equal to 12. Let's use our formula now and let's start plugging things in. So A right here, that's our total amount at the end. A is equal to, scroll back up, P, so P is our starting point, 5,500. Keep going back up to look, times 1 plus R, 0.036, over N, 12. So you can see again, I have my R over my N to the N times T power. So I'm going to put 12 times 3. Okay, now what we're going to do is we're going to just go ahead and we're going to type that in our calculator all at once. What I want you to do is I want you to get your calculator out and let me show you how to type that in. So I have 5,500 right here. So 5,500 parentheses times 1 plus this. So what I want to do is I want to say 1 plus 0.036 divided by 12. Close the parentheses, now to the power. So to get that power, what you want to do is you have this button right here, this little exponent, and I'm going to put times 12 times 3. I want that all in the exponent. If you don't have a newer calculator like that, you're going to want to put parentheses around that 12 times 3. We're going to go ahead and we're going to enter. We have $6,126.27. We're going to round to the nearest hundredth, okay? $6,126.27. I believe it's 27. Let's double check again, since I wasn't, yes. Okay, now what I'd like you to do is I'd like you to pause the video and walk and try number 2 on your own. You'll come back and we'll go through it again. We'll check your answer. Okay, you should be back. Let's digest this problem again. You invest $10,000 in some stock that pays 5% annual interest and is compounded semi-annually. How much will the stock be worth in 7 years? Okay, so here is our starting point. That's our principal. Here is our rate. Remember, we need to move the decimal 2 to the left. 0.05 is equal to R. Compounded semi-annually, that's our N. N is equal to 2. And how much will the stock be worth in 7 years? Here's our T. We're going to go ahead. We're going to say, okay, first, what is A? That's our total amount at the end. Then we have our P. Let me just rewrite the formula down for us, so I don't have to keep scrolling up. Okay? So we have our P, our principal, what we start with, times 1. Okay, so I'm here, plus R over N, 0.05 over 2, to the N times T power. So N is 2, so 2 times 7. And you can go ahead and you can just put 14 if you like. That would make it easier when you're typing it in your calculator. You're going to go to your calculator. You're going to write 10,000 times 1 plus 0.05 divided by 2 to the 14th power, because I'm just going to multiply 2 times 7 out. And I get $14,129.74. $14,129.70, what was it, 74 cents. Okay, so that is your compound interest, looking at those interest rates when you're investing in the bank. Let's look at another exponential application, and that is when things are compounded continuously, okay, compounded continuously. So A is still your amount at the end. P is equal to your principal, that's your start. R is equal to your rate. Again, you need to make sure that it is in decimal form, so change from a percent to a decimal. T is equal to your time in years. And then you'll notice we have this E. This E is an irrational number that is approximately equal to 2.7. It goes on and on and on. It's kind of like pi. Pi is an irrational number. Your teacher in class may talk about that more at length with you, but for now we're just going to use it in our application, and I'm going to show you how to type it in the calculator. Number 3 says, suppose $5,000 is put into an account that pays 4% compounded continuously. How much will the account be after 3 years? So here's our start, our P. Here is our R, our rate, and we need to change it to a decimal. And here's our time, T. So I have A is equal to P, 5,000, E, R, T. So R is our rate, 0.04, times our time, times 3. Let me go ahead now and show you how you type that into your calculator. So you all have your graphing calculator on your Chromebooks. I'm going to put 5,000. And now I need to find the E button. And when I look at this ln, this is a natural log. Right above it, it's hard to see on my calculator here, there's an e to the x power. You're gonna hit second, because it's in blue, that's what we want, ln, and that gives you e. And now I'm gonna put times 0.04 times 3. And I get $563.75. $563.75. And there's my final answer. What I'd like you to do right now is try number 4 on your own, and then come back and check your work. Okay, so what should you have? A is equal to 3,400. That's my initial, what I'm investing, times E, okay, to the 0.046, right? 0.046 times 5. We go ahead, we type that into our calculator. 3,400. Remember that E is that second ln, 0.046 times 5. And I get $4,279.24. And where was I at? And 24 cents. All right, let's move on to our last exponential functions we're going to talk about. It's just the basic exponential growth and exponential decay, okay? So where A is still equal to your amount at the end. This little a stands for your amount at the beginning. Your R still stands for rate, and that is your rate. You want to change from a percent to a decimal. And our T is our time in years. Okay, let's go ahead and let's look. In 2000, there were 420 cars in the student parking lot. If the number of cars is predicted to increase, okay, digest the problem, by 2% each year, okay. From the previous year, how many cars will there be at the start of the next school year? And they're saying that's in 2018. Okay, the biggest thing here is we have to decide, are we using the exponential growth or the exponential decay formula? And we're using the exponential growth because it talks about increasing. Let's write that formula down again. So let's start with A is our ending amount. That's what we're trying to figure out. Our lowercase a is our starting amount, and that's 420 cars. Times 1 plus 0.02 to the t power. Now what is our t going to be equal to? Well, our start is at 2000, our end is at 2018, so that's a total of 18 years. I'm going to go to my calculator now. I'm going to plug that into my calculator. 420 times 1 plus 0.02 to the 18th power. And we have 599.86. And since we're talking about cars, I'm going to go ahead and I'm going to round that up to 600. Now check with your teacher. Your teacher may not want you to do that. Your teacher may just want you to keep it in decimal form. Let's go to number 6. The population at AHS is decreasing each year by 5%. If this trend continues, how many students will be in the building in February 2022? If there are 2,167 students right now. Again, notice that key word, we see decreasing. So now we know that we need to use the exponential decay. I'm going to rewrite that formula down. A is equal to lowercase a 1 minus r to the t power. My lowercase a is my amount at the beginning. My amount at the beginning is 2,167. Times 1 minus, I have 5%, so I change that to a decimal. And 2,167 students. Right now, we are going to assume that right now is 2021. And so we want to know it, and we're going to assume also that it's February of 2021. So we have to make an assumption there, okay? Then now February 2022, so the next year, after 1 year, where are we at? And we look and we see in our calculator 2,167 times 1 minus 0.05 to the first power. And we get 2,058.65. Which is approximately 2,059 students. Again, I'm going to round there. All right, what have we talked about? Just to sum it up, we've talked about interest that's compounded. We've talked about continuously compounded interest. And then we've talked about basic exponential growth and decay problems. If you have any questions, make sure you let your teacher know. And thanks for joining me.